And thank you to all of you who may be in time zones that make this difficult. It's 4 o'clock.
Let's go.
All right, it's the top of the hour. I will say this officially. Thank you to all of you who have joined us, no matter what your time zone actually is. This is the Reliable and Available Wireless Working Group, and Rick Taylor and myself, Eve Schuler, we are co-chairs, and we'll be leading you through this session. We think we have MeetEcho working, but if you're having difficulties, by all means, type into the Jabber window and we'll try to give you some assistance. We'd like to note the usual IETF policies, that you agreed to follow IETF processes and policies, having to do with patents, having to do with your understanding that these sessions are recorded, there's note-taking and so forth, that your personal information will be guarded, and as a participant that you agree to be a nice person and behave professionally and respectfully. If you'd like to see more details about the policies, there are many pointers here for you. These are live pointers in the materials, and just remember that the session is being recorded. If you're seeing this slide, you have successfully managed to join MeetEcho. Congratulations. The nice news is that the blue sheets are automatic this time. We have a wonderful volunteer, Ethan Grossman, who will be typing in minutes. And as with Etherpad, it's a shared set of minutes. So by all means, please, you're welcome to also take minutes with us, with Ethan and us. Remote participation, there are people who maybe have not registered or prefer to just join the Jabber. Here's the pointer, the mailing list, and of course the materials are all on the main site and can be downloaded all at once. Our agenda today is, as you know,
still there, Eve?
jam-packed.
We lost you. Nope, still there. Yes, can now.
So I will be keeping track of the time. It's not personal, but I will be letting people know when they've got a couple minutes left in their presentation. For the longer sessions, maybe 5 minutes. But we've got all 5 of our drafts will be represented and presented, and we additionally have a drill down on the 802.11 update for TSN and localization. So that's exciting. And oops, I went in the wrong direction. This is what our milestones look like. They have not changed, but we're going to have a discussion about them. So I do want to point out that there are 4 boldified milestones here. They each represent a document, and we've got use cases, requirements, an architecture framework document, and ultimately what our objective here is to provide an evaluation of existing technologies and have a gap analysis. So remember that, because we'll have a discussion later. And I'm going to hand over to you now, Rick, but I'll keep going with the slides.
Okay, thank you. So as of the end of IETF 107, which was our first virtual meeting, a number of personal drafts were presented, and there was a call for adoption by the authors for the raw use cases document and the raw OAM document. So we had rough consensus on the working group mailing list for the adoption of both of those documents. But they have not been renamed as working group documents and released, because the chairs have a couple of questions for the working group, and rather than rename documents and then potentially rename them again, we asked the authors to just up-rev the number and hold. And we'll get to those 2 questions in a minute. Since then, we have also had 2 more drafts where the authors are asking for working group adoption, which is Pascal Toubert and the other authors of that on the technologies, and Niels, and I can never pronounce your surname, I'm sorry, Niels Myra, the LDAX draft.
And may I suggest that when people come to the mic, they say their names so we can learn how to pronounce their last names. Thank you.
Actually, yes, that's very important, because some users are on Jabber and this session is being recorded for audio. Can you please state your name at the mic as though you were an in-person meeting, so that it's recorded. So sorry, yes, Niels and the LDAX draft, they've asked for working group adoption. We have not officially asked for it on the mailing list, but they're presenting their updates again, and they've presented a couple of times. So I think there may be some interest in that. Next slide, please. Okay, so this is a concern driven by me, but I believe I have Eve's support on this concern as well, and this is something I've raised on the working group mailing list. So if you look at the charter and particularly the milestones in the charter, they discuss documents that capture the use cases and the requirements and producing a gap analysis. So what I call sort of horizontal documents, which cut through each technology and say, no matter what the technology, the common use cases are X, Y, and Z. Meanwhile, because we have people working in various parts of the wireless industry and the usual people involved in these things, and we all know who we are, we have specializations in 5G or LDAX or 802.11 or whatever. So we have a number of personal drafts asking for acceptance by the working group, which are more technology vertical in manner, in content. So my question to the working group is, how do we align the charter's idea of how these documents should look with how they currently exist in the personal drafts without discarding the really good content? So this is not a criticism of the content in drafts, because I think they're really good, and I think there's general consensus on that. It's not just my opinion. And without annoying the authors so that they stop working because the working group told them just to change all their documents, but still to sort of align with the milestone and charter. So this is something really where this is a working group discussion, and Pascal is jumping to the line. Yeah, can I just have a look? Is there a second slide on this one, Eve? I forgot. Yeah. So yeah. Okay. So just I'm holding you, Pascal. I can see you. Give me a second. So the summary and the proposal based on the feedback from the working group mailing list was, we can either leave the charter as it is, changing the charter, given this is the second meeting after chartering of a working group, I have been told by the AD is an incredibly bad idea because it makes us look deeply dysfunctional. So changing charter, not necessarily a good idea. Changing milestones, that's entirely possible, because that's something the working group can decide to do. So we can remove the requirements milestone if we don't particularly like it. We can change things around. We could add a milestone. By the way,
we've got
for technologies, etc. So, okay, I'm letting Pascal go. Go on, Pascal.
Okay, thanks, Rick. So I can just compare with the working group I'm chairing right after this one. So we have LP1 on the second session, and LP1 is working on an abstract compression mechanism for all sorts of networks, but still we needed to have an idea of the kind of networks we're working on to be able to do the requirements right, to propose the right protocol. So the first thing we produced was this informational document where we listed the technologies that we considered, so we could basically figure out what was the common abstraction of the underlying technology on which we need to base our design. We cannot work just without any constraint or any knowledge of what the technology beneath our ears. So that's why we wrote this technology draft, and I believe that what we had in LP1 is exactly the same here. We need to be able to have a line, a baseline of the abstract underlying technology, and that's so yes, we need this milestone.
We agree with you.
That's it.
Yes, I think we
So this is sort of partially a question to the authors of the 5G draft and the LDAX draft, which is actually, can I hold that comment for a moment, please? Can we move on to the next slide, Eve? Okay, so the other question we have for the working group is, looking at the OAM draft, which is a really good document, the DetNet chairs looked at it as well and said they have an OAM draft charter item in DetNet that nobody is authoring at the moment, and the OAM draft put forwards into this working group, they considered maybe 70% of it was generic enough to actually satisfy their charter item for an OAM draft. So the authors of the draft and Eve and myself and the DetNet chairs put a call together last week to discuss this, and we are all in rough agreement that we can move the vast amount of the current OAM draft in this working group could actually be moved to DetNet and become a DetNet working group document. But the raw specific parts would remain in the OAM for raw draft in this working group. So
we're at time.
In the DetNet working group on Monday, we're at time. I'll be quick on this. In the DetNet working group on Monday, there was consensus by the DetNet working group to accept this proposal, but we do need to confirm that the raw working group is happy for this as well. And I'm also happy to take this to the list. Pascal has a comment quickly.
Yeah, I mean, I was there creating DetNet from the beginning. My belief is that the DetNet requirement is a subset of the raw requirement, curiously enough. We have bigger and harder needs. And so the way I would like it to be done is more like we progress the document till we are sure that we have everything that we want covered. And then if the two working groups want to collapse the two documents into one and finish it at DetNet, I'm perfectly fine with this. But having to convince DetNet step by step of everything we want in this document and having to negotiate that at DetNet kind of kills the whole need for raw. I think the value of raw is to make sure that we do progress on our needs very well. And then when we know exactly what we have and what we want, we'll be able to analyze how much of that, how we share and merge with DetNet. I would like to do the work here.
And somebody needs to
go ahead,
their
Lou.
mic a
I
little
was
bit
hoping
further
you were
away.
going to
We can hear
answer.
you breathing like this, so, okay.
Hi, this is Lou Berger as DetNet chair. So to be clear on what was discussed on Monday, there was good agreement in the room. We can't really do consensus in a meeting. We have to do consensus on the list, but I think we're headed that way. I believe the proposal was that the generic portion of the OAM document, which there was apparently a good amount of content originally, in the latest version, I believe that's been removed. And so the thinking was take that generic portion, do that in DetNet, keep the raw specific OAM considerations in raw and work that in parallel. And if there's more generic pieces that are identified, move them to DetNet. And definitely there's no intent, at least from the discussion as I understand it, to stop raw specific OAM discussions in raw. We think that's my personal opinion. I think that's very important. My reading of the room on Monday was we were expecting
and to note that there is overlap of
parallel,
the
not
authors
to stop the
for this
activity.
OAM drafts, so that shouldn't be a problem.
Yeah, so if I didn't make myself clear, the intention is exactly as Lou described, to work on the to split the documents and work on them in parallel. So I think we should take that one to the mailing list. However, this very quickly, jumping back to my point about alignment, my question is whether the authors of the LDACs and the 5G, these technology vertical drafts, whether we can ask, or whether the working group should ask them to contribute some of the generic, the technology agnostic generic components of those drafts to Pascal's proposed technologies draft and readjust whether the working group thinks it's worth people doing that. Sorry, Janos is jumping in. Go ahead, Janos.
Hi, everyone. The 5G technology draft is already rolled into the RAW technologies draft. So we were heading to this
since
direction,
the last
or actually
IETF, so that's been
we
great.
made at least the very first step. Yes.
Go ahead, Pascal.
Yes. What I want to say is the technologies document has a very fixed format. We are asking all the participants, and Janos will talk about that, just added 5G, to provide us with a very specific format so that we can actually derive a generic format that would cover them all. The intention is not to describe in dear details what each technology is exactly. And still, there is interest in doing that. But for that, we did not want to impose a form. So basically, you can see the specific technology documents like Janos or Niels as being free form, so they can really put whatever they want in there and give all the interesting information. Whereas the technology is very constrained to provide very specific information that we ask. So they are complementary. They are not doing the same thing.
Yeah, I personally am in agreement with you that is
Yes.
the
And I was
correct
going
way
to
to move
suggest
forward.
let's
But this is a
continue,
discussion
and
that
in the interest of
we need
time,
to
please move
continue with the
on so we
working
have a
group.
little bit of time
So,
at the end for discussion and wiggle room for the other presentations. Okay? Okay. Thank you. All right. So I'm going to stop presenting. Let's see. What do I need to do here? Can you manage it from your side? Okay.
It's Carlos first, isn't it? I hope so. So Carlos, you have the mic.
Yes.
Can you share your screen?
Okay. I thought that you will be driving the slides.
I think it might be easier if you can drive it. We have your slides if you would like us to drive it.
If you can do it, I was expecting that I should be fine either way, but so let me know.
If you want to try driving first.
Okay.
I will accept your screen, and hopefully it will all work. Yes, I can see that. Okay.
Perfect. Okay. So I'm Carlos Bernardos, and I'm presenting this on behalf of the co-authors of the RAW use cases individual draft. I'm going to try to be brief since we are a bit over time, and we don't have like big updates on this draft. So currently in the draft we have like 8 use cases. I think I'm missing something in the index in cover. And there is one difference from the previous version that was presented in IETF 107. That is the last one on emergencies, in a particular subcase of emergencies, which is having instrumented emergency vehicles. And there have been minor updates on the other ones. So initially, I wanted to focus on a couple of use cases, the same that I focused last time, but I think I will just present one of them for the interest of time, which is the wireless for industrial applications. Just trying to actually not focus in the use case, but more on the structure that we use for all the use cases in the document, to see if we get any feedback on whether we should change that approach or we can improve in some way. So let's move to this use case. That is an example, the wireless for industrial application, that I think is a very relevant example for raw technologies. So we have an industrial factory or plant where we have different devices, actuators, and sensors that may be wirelessly connected, or also connected by wire. So we may have DetNet kind of networks in addition to wireless multi-hop heterogeneous networks. We have control loops, and we have monitoring traffic. So we have a mix of traffic there. And for some of these flows, we really need to provide reliability and availability warranties. So in the draft, for each of the use cases, what we do is to have an initial description of the use case, something like this picture kind of describing text. Then we have a more detailed section on the specifics of the use case, considering the wireless approach and the actual specifics of the particular use case. For example, in this case, the fact that we may have heterogeneous wireless technologies and wired technologies is a key specifics, that we may have multiple simultaneous links transporting or sending or traffic for the same flow is also a relevant characteristics, that we may have variable link conditions, even if we don't have a lot of mobility in this scenario, because things are moving. I mean, we have mobile parts in robots that are moving and that may change the characteristics of the links, and that we have different traffics with different needs. Control loops, we have reliability key there and low latencies required, but then we may also have monitoring and diagnostics traffic that don't require that amount of reliability and availability, and that shouldn't be mixed with the other kind of traffic. Then we have a section on basically on the need of wireless, which I'm skipping in the presentation because it's kind of obvious for all the use cases, and maybe we need to remove in the draft. That's up for the discussion of the working group. And then we have a section on specific requirements. That going or linking with the previous discussion, if we kind of merge these two milestones of the group, the use cases and the requirements, that will be a key part of the draft as well. In this case, for the wireless for industrial applications, the two key requirements are that on the one hand, the solutions must be backwards compatible. So we need to be able to support both regular kind of multiplex flows and flows requiring predictable behavior, and that the solutions should also work covering or over multiple technologies, wireless and wired technologies. So we may have a segment that has a wireless TCH, and then we may have a backbone segment using Ethernet or Wi-Fi, and we should ensure that the solutions work over this kind of multiple technologies segments. Then here I will have another use case, but I will skip. Basically, this is the gaming one, and there we have more specific kind of requirements, for example, for latency, but this is just an example. And then if I go to the last slide, just to conclude. So in the current draft, we have eight use cases already covered. There were others mentioned in previous meetings, like smart grid. So if people consider that this is an important one, please say so and provide either text or a pointer where we can start looking into requirements and specifics for that for RAW. As the chairs mentioned, we went for working group adoption after 107, and we got positive support. So question to the chairs will be whether we should do it, and when, if so, submit as draft IETF. And then question for the rest of the working group, whether we should document additional use cases, and maybe we should start working already with the authors or editors of the potential draft IETF RAW architecture for working on the requirements, so better characterize the requirements. And that will be all from my side. I try to keep it short.
Thank you, Carlos. So one note is the chairs. Let me think what I'm trying to say here. Yes, so the use cases has been adopted. So I think after this, for the next revision, you should rename it. I think we're fine. It's not going to be affected by the reorganization. So there's
okay.
Go for it. Rename it. It's on the charter. So
okay.
Okay.
Thank you.
So if I now click the magic button,
the agenda is
away.
that
There we
Dave
go.
Cavalcanti is going to talk about 802.11 update, and let's let him in. Let him in with the audio. And then, Dave, are you comfortable sharing your screen? Yes,
click.
you can.
Sure. Can you hear me?
Yes, we can.
All right, great. Hi, everyone. Let me try to share here. Okay.
Wow. Yes, there we go.
All right.
Yep, that's good.
Okay, so thanks again, everyone, for the opportunity to present here today. My name is Dave Cavalcanti, and I'm co-author in this presentation with Ganesh Vekatizan, both from Intel. So we'll provide an update on Wi-Fi, and more specifically on the TSN related capabilities, and focus on low latency and determinism, right? So we presented a couple of meetings ago, and we'll focus more on the new developments and Wi-Fi 7 capabilities and localization as well. So these are a short outline. Just a brief mentioning on the use cases. We just heard about those. And then we'll go into some of the TSN capabilities over Wi-Fi that has been developed already. And then we'll go into the scheduling enhancements in Wi-Fi 6 and 6E and the newer capabilities towards low latency and higher reliability in 11B and Wi-Fi 7. And finally, we'll give a short update on the localization capabilities. So as you know, Wi-Fi is really pervasive today, right, in most environments, both in consumer or in enterprises, and but specifically, for example, in industrial, and that was one of the use cases discussed in the draft, right? Wi-Fi is not yet used in this new time-critical type of applications like robotics, autonomous control. And that is the new opportunity, right? That is driving a lot of the new developments in technology and Wi-Fi. And the key goal there is to how to make it more accurate in time synchronization and more predictable in terms of latency and reliability. Other applications also include gaming, AR, VR. So those are really the ones that are driving these new developments. And that's why we think, you know, it's very relevant for this group to understand those features. And that's what we'll try to provide a little bit of an update today on that. The .11 group has looked into a number of use cases and requirements recently, and these have been documented and can be accessed, you know, in this intergroup report that is available. And you know, there is a presentation and a report with detailed requirements. And as you can see in the list, I won't go through all the numbers, but robotics, industrial automation, and gaming were the main driving use cases, you know, which seems to be very aligned with the use cases in RAW. One takeaway from this report and use cases is that the main challenge or gap at this point is really enabling, guaranteeing worst case latency and jitter, right? You know, in other words, more determinism in Wi-Fi. So and that is driving many of the new developments in the next generation Wi-Fi standards that we'll talk about. But already in Wi-Fi for quite some time, you know, there has been work in collaboration with the 2.1 TSN working group, and I borrowed this overview figure from Janos to illustrate here that you'll see there are many TSN components as you know as part of the toolbox, right, of TSN capabilities. But what I wanted to highlight is that in this each of these areas, there has been work in Wi-Fi to enable those TSN capabilities over .11, starting from time synchronization and then going into latency with the scheduled operation now available with the 2.11ax, and additional enhancements that are coming up with 11BE. Reliability also has been enabled. It's possible to use .1CB over Wi-Fi and now multi-link operation has been added in 11BE. So we'll talk a little bit more about each of those capabilities. So first, as we know, time synchronization is a core feature, right? To do scheduling of data at the right time, right? With determinism, and this has been already enabled in .11 for a few years. The 2016 specification adds two protocols, timing measurement and fine timing measurement protocols for time synchronization. So the fine timing measurement is a more recent update to that, and it has several advantages where stations have more control of the execution of the protocol, and there is a higher resolution in timestamps in the hundreds of picosecond units, 48 bits fields for timestamps, and you have a capability to measure asymmetric link path delays there. And this has, potentially a higher accuracy comparing to time measurement. But the point is, like, both of those can enable time synchronization and operate with the TSN.1AS time synchronization protocol. And in addition to time synchronization, you actually get geolocation and positioning as an added value, and we'll talk more about that at the end, which may be another benefit from many applications. And so in addition to time synchronization, another important feature in TSN for many of the industrial applications is the capability to do time-hour scheduling or time-hour shaping. And the basic idea can also be applied in Wi-Fi, where you can control the different queues in a Wi-Fi station and network in a time-aware basis, so that the right queue or the right station is allowed to transmit at certain times, where the other queues are closed. And of course, this is part of the implementation in a Wi-Fi network or BSS. You have a scheduler that is able to coordinate this schedule and achieve the hard deadlines and bounded latency with reliability. And this feature, when combined with the recent update in the Wi-Fi 6 or 11AX specification, which adds a trigger-based schedule operation, it's very powerful to achieve the latency and the reliability guarantees that are expected in many of those applications that we discussed. So here we show the overview of the trigger-based operation that was introduced with 11AX. There is a basic exchange where the access point sends a trigger frame and then schedules multiple transmissions in different resource units and in our OFDMA based PPDU, and followed by a block ACK. So this operation allows you to transmit multiple frames simultaneously, and there are multiple configurations and allocations in terms of amount of resource and MCS that every station gets. And with this capability, the AP can basically schedule and try to meet deadlines, right, with reliability constraints as well. So what the figure on the right shows is a simulation where we look at a number of stations in a certain area and try to find, given a latency bound, right? If I have a deadline, how many stations, and that's the capacity here, how many STAs can be supported for a given latency bound with 99.99% reliability. And this reliability means here the fraction of packets that successfully delivered within that latency bound. So as you can see in the figure, for a given latency bound with the 11x trigger-based access, you can support a certain number of simultaneous stations, right, with 100 bytes packets in this case. So from 9, if you have 1 millisecond bound, to 45 if you have 3 milliseconds. So there is a trade-off, of course, between latency and the capacity here. But just it's important to understand, in these simulations we use 20 megahertz channel, and in Wi-Fi you can operate in 20 megahertz, 40 megahertz, 80 megahertz, 160. So this capacity can be extended, right, if you use more bandwidth as well. But the key point is that now in the 11AX we have this capability to schedule operations, and that can be used to provide this new type of service. So another important new development is the Wi-Fi 6E, which means 11AX operation extended in the new 6 GHz band that has been opened up in the US and is in the process of being opened in many countries. Products with these capabilities are expected to launch, and Wi-Fi Alliance specification certifications expected to launch in January next year. So this is seen as a very significant enabler for new usages that really require more determinism, because legacy Wi-Fi devices like 11AC, 11N, and before won't be able to operate in this band, right? So this band will be used only by 11AX devices and beyond, right? Which have this scheduling capability. So that limits already, some of the issues with legacy devices. And also important to note here, given the amount of new spectrum, and you can see here the number of new channels that become available that are significantly higher than the previous bands, you have more flexibility to really adapt the network to interference and congestion and become more resilient, right, to any unmanaged threats that may occur, right, because it's still unlicensed operation, right? So other systems can show up in the band, but with this availability of spectrum, you can monitor the network, you can adapt, and you can apply redundancy, which are important features that RAW is probably going to develop as well. So now shifting to what is coming next, right? And it's going to be called Wi-Fi 7, but this is basically the work being done in the new 802.11b task group that started in EEE. And there are many enhancements in different performance vectors, from data rate to efficiency to energy efficiency. But the thing that is more interesting for this group is probably the specific enhancements in the area of deterministic low latency communications. And there are a few capabilities that are being developed, specifically addressing low latency applications, which are multi-link operation, multi-AP operation, and channel access enhancements for more deterministic operation. So the multi-link operation is a new feature, and it's really one of the key features in Wi-Fi 7. And the idea is that you're gonna have a device that has multiple links. So a multi-link AP would be an AP that has actually multiple APs inside it, and each one can be operating on a different link. And the same for the stations. You can have multiple stations in the same device operating simultaneously on multiple links. And obviously, you get throughput enhancements with this link aggregation. But more importantly, we also get lower latency, right? Because you have more capabilities to access the channel. We can also get higher reliability because we can duplicate packets over multiple channels or multiple links. And we can also do traffic steering and separation, where certain traffic can be steered to certain links. And that is also a mechanism that can avoid congestion, right? So these are new tools that can be used to provide this low latency and or reliability, right? Of course, with the higher throughput gains. So these are some of the key features for new applications like the industrial and gaming or VR. Another important feature is the multi-AP coordination. So multi-AP here means a collection of features that try to enable more direct coordination between multiple access points to achieve certain performance goals, right? And there are different flavors of multi-AP coordinations being considered in the spec. And there are some of the schemes that are more MAC-lay oriented in terms of coordinated FDMA, spatial reuse, and coordinated TDMA. And also some more file level features like being coordinated beamforming or joint processing. The key point here is that we are extending this coordination, and you saw the scheduling capabilities, right? That 11AX is enabled. So this coordination will extend that beyond a single basic service set or BSS, right? Or a single Wi-Fi cell to provide more control over, for example, latency or reliability together with multiple APs in a certain area, right? So this will address some of the previous limitations with the overlapping APs.
Dave, you've got about 3 minutes left.
I'm almost done, thank you. And the final enhancement is in the area of latency, right? So we know that the 11AX can achieve single-digit millisecond latency already, but the worst case latency can still vary with congestion. And we know that with the higher bandwidth in Wi-Fi 7, we can, in multi-links, we can get even lower latency. But there is still need to enhance the operation towards more deterministic behavior. And there are a number of features that are being introduced with new QoS provisioning models. Also, the idea to create dedicated low latency access categories and introducing this concept of time-aware scheduling inside the 8.11 MAC, and with some additional work in the area of preemption and limiting the transmission durations. So those are all enhancements that are being discussed at this point in the group. And so finally, just to add that, we also have in Wi-Fi localization, right? With FTM, you can achieve in line of sight around, a bit less than a meter in accuracy. So stations can do positioning with that, and applications that cannot access GPS could leverage these mechanisms as well, which is the same that can be used for time synchronization. And then there is enhancement ongoing in 11AZ, which extends some of the ranging capabilities. So as a summary, we have seen a lot of these capabilities already exist in Wi-Fi, but more are being introduced. We have captured some of them in the technologies draft, but perhaps some of the latest development in Wi-Fi 7 features can be updated because there has been more development, and we know more now what it will be coming up in Wi-Fi 7, and I think that can help drive the requirements and the solutions in this group as well. Okay, thank you for listening. Yeah.
Thanks, Dave. There was a question. There's also, let me get to the question that was on the chat window. I think Lou, you had posted. Did you want to get mine to? Why don't you get mine to post it? I'm
going to let Lou jump first, Steve, because he asked on the list, and then Eduardo I'll jump to you. Go ahead, Lou.
For trying to put it in Jabber to be quick. Just a question: how is QoS provisioned or controlled? Are these in the new capabilities that you're describing?
Can you say again? I think I lost you.
With the new you're describing, how is QoS provisioned or controlled?
Did you get the question? It seems like it's breaking up here for me. It's something around QoS provisioning, right?
Yes, with the new features. Yes, with Wi-Fi 7.
Yeah.
exact question on the Jabber was, scroll down there. How is QoS provisioned and controlled?
So one of the new updates in Wi-Fi 7 is that we are trying to introduce again a mechanism for stations to negotiate QoS. Basically, the stations provide its requirements and the network do admission control based on that. And we are proposing a type of new service around low latency with high reliability that can be negotiated. And there will be new signaling to establish that. And then some of the other capabilities listed here are going to be used to provision, right? Some of these new queues or new time-aware functions to allow scheduling enhancements. So this is, QoS is all part of QoS provisioning. So we include new signaling and new enhancements in channel access as well, linked to those specific traffic streams that are admitted. So admission control will be part of that as well.
Okay. Edward, go ahead.
Hello, do you hear me?
Yes.
Okay, I have a comment about latency, because I was surprised when I hear here that latency would be 10 times worse compared to 3GPP, to 5G, for example. In 5G, latency for wireless link is half a millisecond by standard, and some vendors have shown even 1/3 of millisecond in real test. Why it's important? Because if you have human and you would like to be human real time, you really should have one-way latency 5 milliseconds for everything, for all transmission. If you have time, I could explain you why 5, because it's easy to calculate. It's originated from 25 millisecond resolution, which human has as a human. But okay, 5 millisecond latency one way. In 3GPP, because you have only half a millisecond by standard, you still have a budget to have long distance, to have some long fiber. Long fiber, I mean, a few hundred kilometers. It still be, your application could be still in neighboring cities. It's not mandatory to have application in the same metro. It could be in different city. But in Wi-Fi 7, as I understand, you still plan something like 5 milliseconds. It's a whole budget which you have for human real time. You don't have anything more. It means that your application should be always in the same metro. Small distance, small, I mean something like up to 50 kilometers, 20, because speed of light in fiber is 5 microseconds per kilometer. For that reason, you are restricted to some metro. If it's exactly what you want, if you would like to have only so-called local communication, it's not wide area network, and you will always would be behind wireless 3GPP, then okay, it's fine, it's your choice. It's a use case, it's exactly what you want, but okay. But I'm just trying to check that you do understand that you have no budget left for really long distance for fiber, effectively for fiber, no budget.
Thank you, Edward. Can
I'm not sure I got the question exactly, but just to clarify, the latency in Wi-Fi, it can be a few microseconds actually. Because there is no fixed frame structure. So depending on your data size and bandwidth, it can be 200 microseconds, right? So there is no limitation in that sense. I think the number you called here, 5, is more user requirements that, if we are targeting applications that from end to end are those, are trying to get those requirements, right? 5 milliseconds, for example.
Thank you, Dave.
Yes.
Sorry, I'm going to interrupt. Can you take that discussion to the list? I think it's very useful that you guys want to compare and contrast. That's absolutely great. Can I ask a question to Dave and the rest of that team? You presented a number of the IEEE use case analysis. Are you happy to liaise with the guys, the author team for the
Carlos and friends?
Carlos, thank you. I am terrible with names. With Carlos on the use cases draft to make sure that we've captured some of the use cases you've highlighted. That would be really helpful.
Sure, and I believe we did share these previously, and they are there. But I'll be happy to follow up on that too.
Thank you very much.
Okay, the next in line is Nils, who's going to tell us how to pronounce his name, his surname, and he's going to present the LDAX. Nils, are you comfortable presenting from your computer? Let's get you in the queue.
Go ahead, Niels.
Okay, perfect. Yes, I hope you can hear me.
Yes, we can.
Nice. Yeah, it should be doable. So presenting.
Go.
And please state your full name.
Yes. Just looking which screen I should share. There we go. I think that's
perfect.
the right one. Okay, so actually, here's a funny story. So my German name is Niels Meurer, and I have no idea how to pronounce that in any English fashion. So it might be Niels Meurer. No idea, actually. So there's no book on that. Anyway.
Thank you.
Anyway, so yes, welcome everyone. Thanks for joining. So today I'm going to present an updated version of our LDAX IETF draft in the version 04. At IETF107, we presented version 01, and since then several things have changed. So next slide, please read and note well, but I think we went over that already. So that is the abstract for our draft. There's one important line that we added since then. It's the last one: high reliability and availability for IP connectivity over LDAX are essential. I'm gonna tell you exactly why we added that line. Here you see the latest contributions. Most importantly, in version 02, we corrected some minor typos and added some new figures. And then the real new value came in with version 03. We added an entire chapter about the applicability of LDAX. So we talked about advances beyond the state of the art. Also about different applications coming into the field. And then in version 04, we added an entire chapter about reliability and availability measures that is incorporated in the LDAX protocol stack. So here, perhaps before we go into the advances beyond the state of the art, here I would like to draw a little picture so everyone is with me. In the aeronautical communications, what we have in Europe mostly is we have sectors in the sky. That means an air traffic controller controls a very small sector in the sky where aircraft pass by, and then they go to the next sector and the next sector. And in 2004, there was the first attempt to unify that into one sky, so into a sectorless sky. And for that, new data links were needed. And since then, those data links are being developed. And as of now, there are several digital data links for safety of life communications, for aeronautical communications. One of them is, for instance, VDL Mode 2. That's a data link. I think it was standardized in the 90s around then, and provides about 30 kilobits of netto data. And this is also what LDAX now brings into the table. That's we have now priority mechanisms for different types of services. So for instance, aeronautical operational control, AOC services, which has low priority, doesn't need to be as quickly at the aircraft as possible, and medium and high. High would be safety critical aeronautical traffic services. Also, and that is actually a funny story because I'm currently writing a survey paper about that, is the lack of security, cybersecurity within most digital aeronautical communication systems. And so LDAX brings a whole range of that to the table that is most known to all of us, I guess, but it's not usually standardized in most aeronautical protocols. And that would be, for instance, key and trust management. There's another a system for airport communication called Aeromax that also has a PKI already incorporated into it. LDAX would probably go with the same procedure. We have mutual authenticated key exchange protocols, key derivation measures. So because one of the 3GPP guys was here, so basically following the same approach. So we do an attachment procedure, and then afterward we secure the link to the management entity within the ground network, and then the communication between aircraft and ground station is especially the signaling or control plane is secured afterwards. We have secure logging and availability robustness measures that I will talk about in a moment. And comparatively high data rates, I know those don't seem high if you compare it to 5G or something, but please keep in mind there are studies that an aircraft at the moment is perfectly fine with about 1 kilobit of data per aircraft, and LDAX assumes to have mostly up to 500 aircraft in one cell. So 1.5 or 1.4 megabits would suffice for that. And also please keep in mind that LDAX only has 500 kilohertz of bandwidth. So it has way less bandwidth and spectrum than, for instance, 5G has. Then here we see the applicability and where LDAX comes into play. So we have SATCOM communication for oceanic, polar, and remote domains. For airport communication, I already mentioned that. That's Aeromex. That's already in use. And then there's the LDAX Air Ground Link that I'm talking about right now. So this Air Ground Link enables new services, for instance, like 4D trajectories, so virtual points in the air where aircraft can fly by, and a broader controller pilot data link communication, so to CPDLC link, business communications, and also LDAX can be used as APNT navigation as alternative to, for instance, GPS. And last but not least, there's also an air-to-air extension, so aircraft can talk directly to other aircraft. So that's everything that we added in version 03. Now in version 04, we added the robustness measures. This is the protocol stack of LDAX, so the physical layer, MAC layer, data link services, DLS, LME is the LDAX management entity, and SNP is a subnetwork protocol. And at the MAC layer, we have a static frame structure that I'm going to talk about in a minute. Then the LDAX management entity is robust resource scheduling that's entirely ground station controlled. And also, for instance, there's the event that the ground station sees there are too many aircraft now in one cell. It can tell neighboring ground station to do a handover procedure, so that cell run at a good capacity. At the data link service, we have a selective and repeat IRQ protocol, ensuring timely delivery, especially of messages with higher priority. And the physical layer in the forward link, so that's from the ground to aircraft way, we have a continuous OFDM stream, and on the reverse link, we have radio bursts, so OFDM, RTDMA bursts with robust and adaptive coding and modulation. And now for the static frame structure, this is now important because here you can see it. So we're talking not about a third of a millisecond. So one super frame has actually 240 milliseconds. This very, very robust static frame structure is required because in the L-band we have several legacy aeronautic communication systems such as distance measuring equipments, which are very loud in a manner of speaking. And so the LDAX system was designed as an inlay system to be robust against such high bursts. And so this is why the static frame structure has to be so robust, and also these times have to be chosen. Here we see that in the forward link, we have a broadcast channel where a ground station announced their existence to the world. We have several multi-frames, that's MF. And in the multi-frames, we have a data channel, that's the DCH, and the CCCH is where resources can be given to an aircraft. And in the reverse link, we see that there's a random access channel with 4 multi-frames, and aircraft can request resources in the DCCH as the dedicated common control channel, and then a data channel afterwards. So this is now the entire static frame structure.
Niels,
then
you've got a couple minutes left.
Perfect, thank you. And then there's an update already waiting for version 05, because thank you very much for the feedback so far. We've received some, and we're currently in the process of incorporating that into version 05. And we're also working on pointing out more clearly why LDAX is required, what problems it solves. Then also the interoperability and modularity of the LDEX radio is one point. Then we had a very good comment about the amount of terrestrial access points, because LDEX cells can have a huge range up to 200 nautical miles. And the question is that a little bit too much? So if you reduce that, do we have more capacity in the cells themselves? Then security relations that need to be clarified, and also the application of quality of service communication to LDEX. So those are in the pipeline already, and we welcome any more feedback. So please go deep and read our draft and give us the best feedback you can. We highly appreciate it. Thank you. That's it.
Thank you very much, Niels. A quick question to the author team. You mentioned on email quite recently that you were looking for working group adoption. Are you officially asking for it?
Yes, we are.
Perfect. I will make a note and we'll make that request on the mailing list as required. Thank you very much.
Thank you.
And Pascal, you are up next if you want to present from your computer.
Oh, click the button.
For sharing.
No, that was me. I double clicked. Sorry, I have to close.
Let me go again.
There we go. That should now work, Pascal. Sorry, that was me. Operator error.
Okay. And let me make sure I select the right application. So you should be seeing my PowerPoint right now.
Yes.
We are.
Okay, so if you don't mind, since we're at it, I started with technology. You have placed architecture and technology. So since we've been dealing with technologies, let me just start with this. So it's a very short presentation. We already discussed why we suggested to do this draft. This draft is there to give raw layer 3 abstraction of this abstract generic raw medium on which we can design. And so to be able to design that, we need to understand the capabilities of the subset of radios that we are dealing with. So we elected a set of radios, and basically we asked specialists of each of those radios to ask to write a section in this draft, so we can actually provide those information. So I just placed an extract from the table of contents on the right, and that extract is from the new edition. Thanks to Janos, we have now 5G, which was the missing piece in this document. Actually, Janos, we'll discuss a little bit about how you arrange things, because this section 6.3 should really be folded into the other. But the main three sections that we have been asking for from all the participants were provenance and documents. So with this, we know where to get the specification. We can also derive whether those specifications are readily available, whether there is IPR, and whether they are from open standards, etc. So we can check they have all the good properties in terms of provenance. Then general characteristics, so we can derive whether they can be scheduled, and obviously they can because that's how we pick them. Or what kind of latency we can expect, and what kind of traffic we can push with what kind of API. And then more specifically, we asked every author or section author to provide us with how and why this technology can be used for deterministic flows. And that's where it becomes very specific to the raw work and what generic abstraction we can derive for that particular radio. And then we would merge that with the other abstraction and build this generic abstraction of all of them. So thank you again, Janos, for this new text. With this, I believe the spec is complete. We have all the major content piece that we wanted. Like I said, there should be for this new section a little bit of discussion between Janos and myself, maybe for just a bit of reorg. But the content is there, just a little messaging. So for this as well, we'll be asking for workgroup adoption. And I understand from the early discussion that it's not chartered, but it seems that it makes a lot of sense to have it nevertheless.
So thank you, Pascal. Rick here. Yes, I will ask for working group adoption on the mailing list. And from a personal opinion, I think this goes a long way to addressing my concerns about having lots of documents about specific technologies without addressing the commonalities for RAW. So I would be very happy to suggest that the working group updates its milestones to include this document, because I think this is a really valuable piece of work. And that applies to the whole author team, not just you. So thank you.
Yeah, I mean, the team did all the work. I just compiled it.
Yeah,
So.
and I'm happy to, again, I think it's perfectly sensible for the working group to adopt now and then keep iterating. You know, we don't have to adopt when it's complete, obviously.
Yeah, it's more like, you know, when the working group wants to have the document, because right now I can decide whatever goes in it, but that's not the goal. The goal is that the working group decides.
Yeah, I think we should be. Anyway, I'll take that to the list because we're short of time. Carry on, Eve.
And then the architecture.
Yes.
Sorry.
Architecture doc, please go ahead. Floor is still yours.
Yeah. So do you see it?
Yes.
Okay, that's good. So I have more slides on this one. So I'll be using the time. Just let me know when we're getting short. So there was a lot of work on this document since last time. We got early reviews when the document was mostly the prime statement. So if you remember around IETF 106, I can't place it with 106, 107, but somewhere between there, I was working on the prime statement. And then the charter came in and said, no, we don't want a prime statement. We want a framework and architecture, blah. So compared to that was actually faster than I thought it would be, right? I thought we would do prime statement requirement, understand where we're going, and then write this framework or this architecture. But the charter was already talking about architecture and framework. So I said, oh, let me try to see how I can revamp the work in the prime statement, because throwing it away was still some waste. So what I called the architecture in the very early version of it was more like the prime statement, just a little bit revamped. And when I got the first commands, and they were very useful, they were really early, considering that the document was not trying to live up to its name yet. So since then, there's been a lot of work. So there were 2 versions published, but also a lot of revamp and a lot of new text. So I put the table of contents on the right. And so there's still a lot of the original prime statement work, so section 3, section 4. So part of that is actually the requirements. So now we have a chartered item for requirements. So you may tell me, hey, you need to split this document, but just that's how life came in, you know, these things evolve. Right now, everything is in this one document. So you can find prime statement stuff, you can find framework stuff, and you can find architecture stuff. And it's at the moment, I'm not very clear on what the working group wants and how we could restructure all this. So I just left it in one document. So for the prime statement piece, there are 2 items that are discussed in the charter. One is how do we interact and what's the relation with other working groups, and the other one is requirements. And I'll go in more slides over those things. Then for the framework piece, right now we have basically terminology. So we need to define what we call reliability and availability in the first place. And so we had this great comment by Janos, hey, we should not be redefining those terms, we should inherit them from somewhere. And actually, the terminology that we use in this document is very little adaptation from the concept in NASA that they use for the space shuttle. And then we look at the gaps, and which is also some discussed in the charter, but what kind of gaps does RAW want to address versus what is being done in the other working groups and what exists already in IP. So that's what I call right now the framework. It's not really a framework. We should have a big picture of the whole thing. This big picture is not there yet, but it would fit in this kind of framework subset of this document. And then I started writing a lot of new text about the architecture, because that's really what people asked on the mailing list. So there are 2 sections right now on architecture. One of them is basically the elements that we'll be using. For instance, these Pareo functions, which are a bit different from the pre-auth, but kind of a small extension to them. And then the what we call wireless tracks, which is this complex multipath, which could be considered as an evolution of DetNet or as an extension to DetNet for less reliable links or something like that. So making DetNet a lot more extreme so that we can cover those very unreliable links. When I mean unreliable, I mean we know we do 5 nines at some point of time, but we never know if there will be something, for instance, in the Fresnel zone that will drop your signal by 20 dBs and causing eye loss, and then this thing goes, and now you get your 5 nines again. And that's what I mean by unreliable. When we want reliability, we want to be able also to say, hey, over time, I will keep providing those numbers, not just at this particular time because we are in the ideal conditions. So that's this wireless element things, the tracks and the power function. And then I started this real architecture thing, which is section 7, where we discussed this PSC that we introduced at IETF106, which is this new element that is actually in the device stack and that makes the path selection for this packet. Then I also discussed the raw OAM design and needs, but it's very high level, right? It's not competition with the OAM spec. It's just placing it as an architecture object. Then I talk about path identification and flow identification. Also, where you make the raw decision, do you make it at the ingress of a path or do you make it along the track when you're doing tracks? Then I'm talking about encapsulation and decapsulation. So as you see, that's a lot of change. So if you have not read 3 or 4, then yes, I mean, please do, because there were a lot of changes. So now I'm going slide by slides over those things that are in the spec. So this raw interaction with other working groups was already there in the prime statement. It was already there when we discussed the working group at 106. So I won't spend time on it, but please come back on the mailing list or with questions on this. So basically we're saying, hey, RAW is we are an overgrown subset of DetNet. We are looking at those links which have different properties, so we need to do extra stuff for them. Those extra stuff being optimizing the spectrum and the energy, and at the same time providing end-to-end reliability when a particular link may not be reliable at one point of time. Then we go through the requirements and compare to the BOF. Since with the discussions that we've been having about the BOF and the mailing list, the original BOF basically talked about the wireless mesh and this structure that you can see in this wireless mesh drawing, where you have this little graph and the PSC inside the graph makes forwarding decision, whereas the PC makes global decision to draw those tracks. But at the BOF, we also introduced the need for things like access selection. So Dave, for instance, just told us about this MLD, this multi-link device that we have in Wi-Fi. Janos in his text explains that 5G has done the exact same thing. So you can have one user equipment which talks to multiple base stations. And so that enhances your reliability and your availability. That's exactly what they're for. But in both cases, you're within one technology. Now, a common use case like my iPhone is I've got 4G access, I've got Wi-Fi. I need to get this packet to the internet. Should I use 5G? Should I have 4G? Should I use Wi-Fi? Should I use both and do replication elimination? And that kind of decision cannot be done within the one radio adapter because it's across those technologies. So that's where RAW comes into play even for the access selection. And then you will tell me, hey, you're not observing the cloud itself, right? You're not observing the internet. Yes, but you're kind of considering that the internet is infinitely fast and infinitely reliable, meaning that whatever loss or latency that you have is quote unquote attributed to the access. So as you start thinking like this, RAW kind of moves a little bit away from DetNet because DetNet really considers every hop. I mean, if you break, if you don't have end-to-end DetNet, end-to-end TSNs, all bets are off because you're looking at very hard bound. With something like the access, well, if you can't guarantee the rest of the network, then you cannot guarantee a hard bound. You just want to optimize the quality of your access. If you're just doing that without the outbound, then you don't need to schedule every hop. You can just say, hey, this access seems to work better than this other. And so this access selection kind of operation is new to this draft and was not there at the time of the BOF. It just came out of the discussions we had. So now we have those two major use cases, the access and the mesh, basically. So just some texture about the reliability, and you have this link on the NASA site. Basically, what I'm saying is those words don't come from us. This wording is just a very slight adaptation of the industrial technology, I mean the OT wording, but just applied to networking. So you'll find, if you read the draft, that we use the generic definition and then we say, hey, when we apply this to networking, here is what it means. Then a little bit of gap analysis, and that's when we have this discussion that we had at the BOF about basically the PC seeing a large network and seeing all those links and making long time decision, whereas when the links quickly flaps because there is something, for instance, in the middle, you can't redefine your whole path. You need to do reliability, viability, local decision with this PSC that we introduced. So now we have this comparison between what we do in RAW and what we do in DetNet. And like I said, we can see it as an overgrown small piece of DetNet. We can also see that if we start introducing that there are non-RAW nodes, so I made the generic picture here where you actually traverse a cloud in one of the legs of this particular track. And that cloud is not controlled by RAW. So if you see this picture, you figure that, hey, I can do some OAM on each hop, if you like, some local BFD or using MANE-DLIP, for instance, on each of those links to observe them, but I cannot observe the cloud in yellow here. So I can have a layer 3 OAM, which will tell me from the egress to the ingress what kind of reliability I observe. I can also observe some of those links where you have RAW nodes, but if you go through a cloud, then you probably lose your hop bound, but you cannot observe every hop at the same time. So RAW, we need to agree on that, but RAW may kind of differ from DetNet in that we may need to traverse those yellow clouds and lose the outbound latency at the same time. Then we discussed IOAM and OOAM. Basically, sometimes we tag the packet with some OAM, so we have this little header, and then that allows us to learn something on the way. We need also out-of-bound OAM, which are standalone OAM packets. You may send them from left to right, or you may also send them from right to left, meaning that you send an observation packet from the egress that has to go through the various paths that the packet can traverse, and basically gather information on the way. It's mostly in the mesh case, but the track, and for instance, get all the delete counters on every hop, and then bring the whole story back to the ingress so the ingress can make a decision. So there is in-band OAM with the packet going left to right, or there could be out-of-band OAM left to right or right to a left. If there is a yellow piece, like in the multi-access case, that would be the internet, then we cannot observe hop by hop what goes in the yellow piece. We can observe the layer 2 hops between RAW nodes, and we can observe the end-to-end layer 3. And then this slide is one you saw already at the BOF, so it's basically differentiating the PC and the PSC. So this table is in the draft. This other thing is also in the draft, and it's not a stack, but it's the closest thing we have to a stack. We basically show 3 methods of learning. One of them is IOAM and also iControl. By iControl, I mean if the ingress decides which subset of the track is going to be used left to right, then but the actual forwarding, like replication, can happen in the middle of the network. Then there must be some control header inside the packet placed by the ingress, so that this node in the middle knows that it needs to do this particular replication or not. So there is OAM inside the packet, in-band OAM, but there is also in-band control. So we, from an individual node in the middle, will learn from this OAM and control about this particular packet. It will make a forwarding decision. Should I replicate? Should I just forward it to A or B? And then it may retag the packet based on to provide additional learning for the next steps, for instance, about the quality that was observed so far on the path. So that's the left column. And you see the packet coming from above in the stack and going down over the wireless, over the lower layers. In the middle column, we basically learn, it's just an interface between the lower layer and the PSC, where the lower layers through layer 2 triggers or a DLIP interface tells us about the metrics, what's observed about this particular layer 2 link. And then on the right, we've got the out-of-band OAM, which are packets which circulate between the raw nodes and give us some out-of-band information about the network. Based on all this learning, you see this red beast in the middle, which maintains the forwarding state, which basically says, oh, for this particular flow, here is what I'm going to do, right? And that fits, together with the in-band control, that fits into the forwarding decision.
Pascal, do you want to take questions now or at the end?
We are one slide from the end anyway, so okay. I'm very happy to take question now because the next slide is not related.
Okay, go ahead, Greg.
Pascal, it's very interesting. The question I have is, when you mentioned the out-band OAM, is it like counter collector or telemetry collector out-band, or you include active OAM test packets that are, well, the same, for example, BFD?
Both. Yeah, BFD is very much in there. Yeah, both. So that's why you see that sometimes we. So it's basically if you have this packet going from right to left on my original packet well, let's go back to one slide because that's where it was. So if the OAM packet is coming like something started by the egress, it can be just like a flooded collector, something which floods the graph that we saw this track, but just floods it the reverse way and captures all the measurements that were obtained through layer 2 triggers and DLIP and just aggregates that and sends that back to the source. That's one way of doing it. So that will basically learn what you said, the link states across the path. But using BFD or remote BFD is the way to do this, is one way, classical way of doing this end-to-end layer 3 knowledge that I also illustrated here. When we, when we wanted to see not just the raw node to raw node layer 2 interaction, but the ingress node to egress node result, like the quality of the transmission between ingress and egress at layer 3. When I say raw observes the layer 3 end-to-end operation, the last sentence in this slide, that's, remote BFD is an example of that. On how do we do that, since we are not doing a serial pass, we are doing this graph, is left to be defined. Do we want to observe just one path over one serial path that is within this track, or do we want to observe the whole track? So BFD is very much in there, yes.
But in which category you put the BFD? You consider it to be in-band OAM or out-band OAM?
Well, I see it as out of band because it's basically something. It's kind of a ping, right?
Yes, but again, if active OAM is not in band with the traffic, in my opinion, it's really useless because it doesn't help you to understand their experience. The experience of the treatment that their data flow receives. So being in band with the data flow is an essential requirement for any active OAM mechanism.
And let me just state that we have about 3 minutes left.
Oh yeah, I need to answer that one because it's really critical.
Yeah, go ahead.
The important is that the OAM, whether you piggyback it with the data packet or you send a separate packet. Like I said, part of that is packet going back anyway, so they don't experience what the flow experience, just captures the metrics which were seen when the packets went through. So if you send a packet left to right to see what the experience is, that packet must be treated like any data packet. Otherwise, it doesn't represent anything. I agree with that. This is why you see a whole section in the architecture, let me go back to it, which is actually another differentiator with what DetNet does at this very moment, which is the encapsulation and decapsulation game. You see section 7.4?
Mm-hmm.
We actually kind of mandate that what decides the packet treatment is not the flow. Right now, and I remember a discussion with, we need to have that on the mailing list maybe, basically what decides the forwarding, what the PSC uses as, hey, here is this thing that I'm going to place in this path. That is not the flow. Multiple flows can be treated the same way. OAM packets can be treated the same way.
Mm-hmm.
Pascal,
today you cannot redo that.
Sorry,
Okay.
guys, I'm going to
let's take it to the list.
Take it to the list, because this is important, but a general OAM question, which I think this is an example of where RAW needs to look at what other groups are doing and take their lead. I think you'll both have an interesting question there. Lou, quickly.
First of all, can you hear me?
Yes.
Excellent. Slide 7, please.
7.
Back to a comment that was made, I think, going even at the BOF, is my understanding, and I believe this was the understanding at time of chartering, or the consensus at time of chartering, as an observer and an individual, that RAW provides the adaptation from general DetNet network, collection of general DetNet networks to the wireless network. So it's almost like it provides adaptation to the subnet technology, or collection of subnet technology that are wireless. This picture implies to me that the world is RAW. So it'd be really nice to see from an architectural standpoint how RAW fits in with the rest of DetNet. And from both slide 7 and slide 8, I find that it's really hard to tell. It seems to me that you're saying that the ingress end system is like a DetNet router, and there's a whole collection of a DetNet network around it. That context would be really helpful, at least to me. And I think it's important to list it in the architecture document.
I'm completely with you. That's why I said NVS, because at some point, if we want to address the cases like this, we are not fully inside DetNet anymore.
I don't understand that at all, and that's why I think you have to document this in the architecture to make sure that the working group is aligned in your position.
Gents, the clock is ticking, so I'm going to close it and say, can we take this one to the list, because this is important again.
There was a part B that I've made before. I will not make it now, but I'll take it again to the list. But it would be really nice to see that the prior comments that were discussed are addressed in future versions.
Okay,
so we don't have to repeat the same things over and over.
Pascal, I believe you're asking for working group adoption for this, aren't you? You have one more slide. Do you want to do your last slide?
The last slide is the one I'm presenting. So all I'm saying is this is a slide we presented at the BOF, and we said, what do we need to do? And it seems that we have a check for the first thing. And now we are working on 2 and 3. And I need to apologize to Lou if there is something I missed about the comments. The comments that were made during the BOF were not fully well captured, and I tried to address them, but maybe I missed something. And I really did not really understand at the mic either, but I tried to answer everything on the mailing list. If I missed anything, I must apologize. And yes, please, I'm sorry for once. I will ask you to repeat, but I mean, it will be very bad if I don't manage that the second time.
Well, thank you for a great talk. Very, very interesting. So let's queue up the next talk if we can. We've got Fabrice talking about OAM.
Click.
Yeah. Thank you.
Fabrice.
It works, yeah?
It works.
Okay, let's start. So I will just present in briefly during this meeting the difference between the previous draft and our focus on wireless network aspects. So basically, we now have a section which deals with the specificities of WAN networks. Instead of a wired network, we don't have anymore the link concept because basically in wired network, we have a full click with a quite small packet error weight. With wireless links, that's much more confused because we are large packet error weights, so we have kind of probabilistic graph with wider characteristics, excellent intervals, and we have some implications. So since we have to measure finely the link quality, for instance, with a packet error ratio, but other metrics exist in the literature, and this is very time variant because of mobility, because of wider characteristics. So it has to be updated in real time. Second point is that we still use in wireless networks a shared medium, so we have very low fairness because we have a capture effect. We may have several technologies which use the same ISM band, which is collapsing together. So the interest is that since we have a shared medium, we have a single transmission which is able to cover multiple receivers. However, we have drawbacks since we may create some collision or interference if we don't manage well the transmissions and the forwarding process. So typically, we use very commonly opportunistic layer 2 forwarding. So we schedule several receivers at the same time, and the packet is dropped, is lost, only if both receivers don't succeed to decode the frame. And since two receivers may have very different wider channel characteristics, it is interesting to improve the reliability. So still, the implication on the layer 3 is that all the links are not interchangeable. We cannot consider that the links are isolated from each other. They have interdependencies. So we have to design joint scheduling and routing processes to be efficient enough. So that in mind, we updated also the operation section concerning the changes which are specific to wireless. More or less, this is what Pascal has already introduced. So this is how we may piggyback, aggregate the packets, the control information inside the data packet to reduce the volume of information to push in the network. We have also to verify the connectivity, and that's challenging to detect that some resources, some wider resources are in common for different flows. So for instance, on the right, we have two different cells for two links. So the link AB has the first transmission opportunity in which is alone. So all the transmission will be probably okay if the packet error rate is quite small. However, we share the same radio bandwidth with another link for another transmission opportunity. And it may be very challenging to detect this behavior since, for instance, the second cell should be used only for backup purpose for word transmissions. So typically, we may detect this problem only when this is a worst case. So that's bad. For the route tracing, we have multipath. We may have multiple technologies, multiple forwarders with opportunistic forwarding. So quickly, it may be very complicated to explore all the different paths are changed together. And what Pascal proposed as the BFD approach, how we may collect this amount of information. This is still not an open problem, still inbound and out of bounds. For the administration purpose, we tried to first identify the wireless metrics. So we have still to enrich this set. So wireless metrics per flow, per wider channel. So that's much more complete. And that's a huge volume of information to collect. And more or less, we are not anymore interested in average values. We have other worst case metrics such as the max burst of packet losses because it has an impact on the delay. So that still has to be enriched in the draft. And last but not least, for the management, links are very lossy. So this means that even if we push some control information, either in the data packets or with standalone control packets, we are never sure that they will be received. So the mechanisms we will propose have to be consistent enough with counters, with some mechanisms to be able to recover from partial or total lost packets. So that's still to be addressed. For the replication and termination, so we have still some propositions, but in wireless networks, overhearing is an asset, so it should be exploited in the scheduling process. And in the OAM, we must collect enough information to be able to exploit this property. And as I previously presented in the introduction, the weather conditions are very time variant. So this means that the network must react very quickly to the changes, because we have some obstacles, we have some external interference which may arise in some specific locations. So we must adapt the network to these specific conditions very fast. So it was a very short update of what we modified in the draft. We are still perhaps missing some points, so please raise them. In the next version, we have still to remove some redundant parts with the DetNet OAM. That's still in progress. I guess that most of the parts, 70% of the job has been done. We need figures, and we need to be also much more exhaustive for the list of metrics. So that's the job that has been done so far. Thank you, and I'm open to discussion.
Thank you very much, Fabrice. About the point of removing what is redundant, maybe you could flag it, make it in a separate section, but if you kind of remove it, you make your document maybe less readable. And then again, I would like the document to be consistent, and then once we are already well advanced, we make sure that we synchronize it with the DetNet document. But I mean, removing and putting pointers may be hard to read and not very efficient at this moment.
I fully agree. We have to take care of having something which is readable, but since we are managing both drafts in parallel, I guess we have good chances to be readable enough at the end. Yeah, the idea is to point out to the unnecessary points to the DetNet draft, and here to have something which is self-sufficient to be readable. Yeah, thank you, Pascal.
Okay, so as I mentioned earlier, concerning the OAM split between the generic DetNet OAM and the RAW specific OAM, I will ask the question on the list because that's where we achieve consensus. But the proposal is to keep this document RAW specific, work on it in parallel with the DetNet OAM draft. And to address Pascal's comment, I believe this document should have a normative reference to the DetNet OAM so that the so-called redundant parts are consistently referenced to keep that consistency Pascal wanted. That would be my personal preference.
Yeah.
Oh, Lou, go ahead.
I think implicit in Pascal's comment is a general question that maybe in front of the working group is, what is the scope of RAW? Is RAW broader than DetNet, or is RAW supporting DetNet? And I think this is like the second or third time we're basically hitting that same point. And I think that's something that we really have to agree on.
I agree. This is Rick speaking as a chair. I believe we have been asked by the ADs to keep the scope of RAW under its current charter as short and focused as possible. So I am tempted to say that the focus of RAW currently should be as a strictly wireless subset of DetNet. However, when we have addressed that problem, I personally would have no objection to arguing for a recharter to try and boil a bit more of the ocean. But to start with, I think the steer we're getting from the ADs, and I think Deborah is on this call if she wishes to jump in, is to stay focused and achieve something now, and that means limiting our scope. Go ahead, Lou.
Quickly, Deborah mentioned to me that she was having connection problems. I saw her drop after saying that, and I haven't seen her come back. So I don't know if she's back.
Okay, conscious of time, please feel free to raise this on the RAW working group list, and we can have a slow, considered, and lengthy debate about this. There's a comment on Jabber from Deborah. Her audio is not good. Okay.
How about Pascal? Pascal's in the queue.
Just to mention that initially I was exactly like that, but then we discussed a lot about this multi-access thing, right? And when you do the multi-access, you care about the access link, which is the wireless one. But then there is the rest of the way. And when you want to get feedback at layer 3, you get feedback from the destination on the other side of the internet. And so that's when this gray zone where some hops are not deterministic and do not speak DetNet comes into play. So if we agree that this is within scope of DetNet, there's no issue. If this is out of scope for DetNet, then we need to figure out what we want to do with this multi-access use case.
Okay, so before I let Lou go, Deborah raises on the chat that RAW needs to identify the gaps from the DetNet work. And I'm assuming her point is that once we've determined the gaps, we can work out whether we're going to address them within this charter cycle or not. Lou's dropped off the list. So officially, this is the end, time-wise, or have I miscalculated by 10 minutes? Eve, you were in charge of the stopwatch. Eve is gone. It's just me.
You're not correct. We have till 5:50.
We have 5. Oh, excellent. I've miscalculated by 10 minutes.
No, maybe I've miscalculated. It's too early here. We had 100 minutes.
100 minutes.
Or 110.
100 minutes. So we're failing on the basic addition.
We are.
Six.
So that would be 5:40. Sorry, that would be 40.
Yes. Yes. So I think this is the end of the session. So we have an open mic. If anyone wishes to jump onto the mic now, I know the Meet Echo will kill the session at some point. I believe officially this is the end of the session, but I am very happy to sit here and listen to any further discussion anyone wants to have. Otherwise, thank you very much for attending. Thank you very much, presenters. Eve and I have a to-do list of drafts to ask for adoption on the mailing list. Please use the mailing list. It is the best way to have these discussions because it is recorded for posterity. So in 15 years' time, when some poor implementer tries to work out why a decision was made, the mailing list archive still exists to record the debate as well as the decision. I'm not sure if you have anything else to add.
Yeah, that the channel is open for 10 minutes. So if people have questions and want to use it,
absolutely.
let's use it. And I think we, during the session, we raised the question, we've got 4 documents, 2 of which we have more or less approved to adopt. So we just need to formalize that. And then we have 2, the OAM and the technologies drafts that are under consideration that we will take to the list. So we'll leave you with that.
So I had a question for Pascal, actually.
It's completely related, but when you upload the minutes, some people say that they managed to upload the MD file as is. So if you just copy paste, from the just provided a link to the CodeMD, but if you copy paste that into an MD file, some people said they managed to upload that directly as an MD file and presents well. When I tried through the tools, doing some exercises, depending on the platform I was using, depending on the browser I was using, the MIME type that was used to upload was different, like RTK or whatever, or just text. But the tool would not let it in, saying it doesn't match what it observes, which is plain text. And it would just reject, for some security reasons, would just reject the MD file. In which case, I tried to save the HTML from Kodi, so Kodi will let you also export the HTML. And uploading that worked. Just, that's my current experience. But some people said they managed to upload the MD. So if you have any better news. But uploading the MD as text file is kind of a waste. We lose all the formatting. So we took care of giving you formatting, so hopefully you won't lose it.
Okay, so thank you for that, Pascal. A quick question. The architecture draft, sorry if I named the right thing, you've got the technologies draft and the
Oh, yes, architecture.
architecture draft. Are you asking for working group adoption for that?
I mean, yeah, I mean, as soon as you want. I mean, the thing is, as long as it's draftable, I mean, I can put whatever I want in there. The day it's draft IETF, then you decide what goes into this and not me. So I guess it makes more sense that you guys decide, not me, right?
Well, it's that's a question for the working group. My personal opinion is I think there's lots of great content in there. Whether it lives as one document or becomes more documents if it gets very big or whatever is a secondary question. I think it has value for the working group to work on.
I see you entered. Let me.
Yes, I let you in, Lou.
Yeah, I mean, this is a personal statement, obviously, but I strongly think you have to define what scope you're trying to solve before you adopt the architecture. It's a fundamental question, and you know, Pascal, I get where you're coming from. You know, your head's in wireless, so the world is wireless. But you know,
that's why you're there, Lou. You're the counterpoint.
Yeah. I mean, no, I'm saying this as an individual. You know, that I think it's really important to set that scope first before adopting the document, and to a lesser degree, also how you're going to interact with different radio technologies, because I do think there's a different sets. You know, some radio technologies you're going to want to define your own PARO. In other radio technologies, like what's coming from Wi-Fi, you're going to want to interact well with it. And we have exactly the same thing in DetNet with TSN and pre-auth, right?
Yeah.
You know, is it something we're doing at the DetNet layer, or is it something that's being used at the subnet layer? And I think, you know, that's a smaller point, but also equally important to cover.
Also, Lou, I would add there's an orthogonal question here, which is where the raw developed thoughts about end-to-end metrics about those paths is not used for deterministic, but for reliability, but is actually used for availability. So, can I even send the data? I actually
sure. I mean, that's a deterministic metric. You know, reliability is only one metric. Availability is certainly an equally important metric. I mean, in fact, I think it's the same.
Yeah,
it all goes to probability of loss, and the architecture of DetNet was careful to do that. You know, Pascal was deeply involved, lead author, maybe co-author. I don't know.
I'm here.
You know, you remember we were talking about network coding as a solution for
yes,
for this particular.
Pushed very hard for it.
Yeah. So availability to me is part of the same. It's just a different. It's where you're turning the scale. Right.
What I don't know, Lou, is if this, because people, I mean, these discussions, they came in with this access problem, and it kind of seems to be very, very important in the wireless world. Most of the wireless is not mesh, most of the wireless is access. And so if the group focuses on mesh within every hub being aware, then that's not a very practically useful thing. I mean, it's very nice in the 6-ish world, but it doesn't really exist outside of it. And so what's the use? On the other hand, the very broad use cases, I've got Wi-Fi, I've got 5G, and I want to know which of those two radios I'm going to use to save my battery and to spend less, energy and money. And so that's the very present problem. And so considering that
from an abstract case, that's not much different than a wired access problem, where you have two different paths that give you different service and different costs in them. You know, why is the general selection problem at the access a raw specific problem? Now there's the generic problem that you want to cover for any type network type, and then add in the case of the wireless considerations.
Okay,
I think Lou, sorry, Pascal. Yeah. I think from my perspective, the reason it becomes a raw problem is about the frequency of changes of link quality. I think DetNet, and Lou, you and I have had these discussions before. DetNet, I think, assumes a wired world. And
no, that's
is it not? Am I wrong?
That's where we started, and those were the first use cases. Those aren't the only use cases. If you look at the use case documents, it explicitly covers wireless.
Yeah, I mean, we've been back and forth. I remember Norm at the mic saying, let's exclude wireless because it's just too complicated. And so even if the broad domain has wireless, and I'm very happy it does because I've been pushing for that all the time. But the methods, the work and the mind of people is really for those very reliable and stable links. And so that's why we have this basically overall.
Well, I mean, there's no question we wanted RAW to, I supported the formation of the working group so that we get more attention on this problem within the whole DetNet framework, right? So I agree with you, we need more attention in this space.
So Lou, I think the core of that question that you asked, and for which I don't have the answer, is whether we can traverse a network. So this yellow piece that I illustrated on the picture, which is just a generalization of the access prom, is still within scope of DetNet, in which case we don't have a discussion. We're all very happy already. If it's not in scope with DetNet, then yeah, it might be that we are not even chartered to work on it. But if we are not chartered to work on the access thing, then it's very sad. So that's really my question.
I think it's in charter. I think it's part of DetNet.
Lou, can I jump in a second? Deborah is posting happily on the Jabber chat.
Except that it's not, Deborah, we need you to clarify what you wrote. It looks like maybe a word.
One of them is, the question is not what DetNet is, but it's not what DetNet covers, but what would be the gaps for wireless is Deborah's steer. So she's trying to focus us on not boiling the ocean. But carry on.
Yeah,
for now.
We don't want
but I do want to get people
actually, the comment I was going to make is sort of consistent with what I think Deborah's saying is, I think you're in scope for DetNet, but there are absolutely wireless specific considerations that we need to cover.
So I'm going to interrupt here. I'm going to interrupt here because the next session is going to get the room. And so we need to get going. But let's take this to the list. And this has been terrific. I really want to thank
and gather although not another time.
I want to also thank Ethan specifically for his extensive notes. He's done a great job.
Yes.
So thank you, Ethan.
And I must make a note that we must upload those notes.
Goodbye,
guys.
Right now, so
okay. Thank you, everybody.
Thank you very much. These sessions are never long enough. Thanks, Eve. I will probably speak to you at some point fairly soon.
Okay. I'll give you a call. Bye-bye.
No worries. Cheers all.
Bye, everybody.
And quit.